Matt Schneider from Optika Solutions is the CEO and founder of this company, and he's a very elusive man to get to find. I managed to intercept him at the Australian Computer Science seminar that was held at Murdoch University the other week, and I just looked at how many people in this society, the Australian Computer Society, and there were 45,000 around Australia. Now, we probably number in the 1,000 or so in statistics, but we're the more specialised people. So we're
quality, not
quality. Well, you know, I think I'll just introduce Matt now, and please, we look forward to your talk. Thank you very much.
Cool, thank you. So, good evening, everybody. It's great to be here. I'm going to start out by saying, first thing, I'm really bad at stats. So I actually failed stats first year. I was very lucky enough to get a sup, but I managed to pass, so I was very happy to actually survive and get through. So, that sets the scene. I also acknowledge the fact that in this room there are a number of very well-educated statisticians, and John has had the misfortune of actually having to tutor me in a very deep and dark past. So I survived, thank God. Now, what I'm going to do tonight is I'm going to talk to you about some work that we've been doing with Watercorp, and it's very interesting because I'm more of an applied mathematician, so linear optimization, that sort of stuff, I'm good. And there's this stats thing that I have to do when I have no choice. But I'm lucky because I run a business and I'm smart and I employ somebody. So Prugop looks after our stats. So once you guys really start getting into it, Pru's going to help me out in the hard questions. Now, the reason why it's relevant is when we first started working with Watercorp, what we were looking at was water flow. So effectively a discrete event problem, looking at water, pumps and stations and stuff like that. So fairly straightforward, and it's all quite basic stuff. And then we moved on to looking at how many bores there were in the Perth metropolitan area. And that was really neat because then we had to go and get some data. So we got some aerial survey data, we got how much water households are using, and we were able to build out some fairly cool mathematical models. So far so good. And then we kind of moved into this realm where they said, well, we actually now want to do a more advanced study, and we're really interested in how we can actually model how Perth metropolitan area uses water. At which point I'm like going, cool. So I'm going to build an agent-based modelling thing. I'm going to put discrete event, a bit of data science into it, and it's going to be fantastic. So that was where I was going. So I was feeling pretty comfortable at that point. And then we thought about it, a bit of a whiteboard session, and then we went, actually, that's not going to work. Why not? Well, so we had to resort to doing some stats. So, population dynamics changing. We've got issues with groundwater. We've got 500,000 plus population. And now we need to look at how are we going to sample it. So, we went, no worries. What we're going to do is we're going to sample every single household, and we're going to look at every single house and how they use people. So we're going to look at people, population, and water. It would be really easy. Unfortunately, what we found out was that actually wasn't going to work. So we spent maybe about 2 hours on that as an approach before it was politely pointed out to me that was a really cool idea, Matt, and there's actually better ways of doing it. Stats. And then we moved into this wonderful world of looking at how do we look at population sampling. Now, when you start looking at population sampling, and there's lots of different techniques, and you can, based upon the type of techniques that you choose, it has biases, and there's all sorts of other interesting problems associated with it. So what we chose to do, we went, well, how hard is this thing going to actually be? So what we did was we looked at ABS data, and we got the ABS data, that's a pretty good start. And at this point in time, what we were looking for was population as humans. But then it became really clear when we looked at the data that actually what really mattered was actually the size of the land. So suddenly what we were looking at wasn't people, we were actually looking at land sizing and land topography. So suddenly we moved away from what we consider to be a traditional population sampling perspective, more to an urban form problem. And then what we wanted to do was say, well, how can we now apply sampling techniques to a population density which is based upon area? So it's like pivot. Now, when you're looking at sampling, we've got different techniques. So you've got systemic sampling, quota sampling, judgment, etc. My personal favourite is a technique called snowballing, which is effectively where you've got a small group of people and you actually ask them to pass you on. So, for example, I go to Alec and say, hey, Alec, mate, let's do a survey. That's pretty cool. Who do you know that would be interested in doing a survey? And I might say, actually, John will do it, and so on and so forth. So that works very well in remote Aboriginal communities, and we've used that technique before when we're working with Horizon. But when you start looking at the Perth area, how are we going to go about doing it? And what sort of margin of error is acceptable? So, to put into a bit of context, what we did was we can do some really funky stuff. So what we're doing here is we're actually looking at households, landfall, how it's being used, overlaying with ABS data. We can also start looking at how people are using it. So what we're popping up on the screen now are different types of latitude, longitude. We're looking at where the bores are, etc. And now we're overlaying the ABS data as well. So what we're now trying to do is we're now trying to piece together all of the available information that we have, both publicly available, ABS, and privately available, i.e. water use within the data sets which Watercorp has in their system. Where this now leads us to is we move into effectively a mixed method study. So now we're thinking, okay, we have a mixed method study, we can take the ABS data, we can take weather data, we can take how people are paying, start building up this coincident data set. But we're still stuck because we've worked out that it doesn't actually matter how many people you've got, it's actually land size. So we're dealing with effectively two different techniques and two different approaches. So therefore we're trying to figure out, well, how do we actually tell this story to the customer? So we then started asking key questions. How are we going to go about doing it? How do we observe the data? What is going to be the observable aspect, non-observable, observable, and then ultimately, how large does it need to be? So, for the customer goes, Matt, it's really simple. We want you to survey everybody. Okay, so we need to go and do surveys for 500,000, 600,000 people. Yeah, it's a really good idea. Okay, and it's going to cost about $1,000 per person. Oh, that's expensive. Okay, so we can't really use an exhaustive approach. We have to do something a bit smarter. Oh, is that possible? And the response was actually yes. So what's fascinating for us is it's about actually taking the customer on a journey. So I mean, in this room, mixed method, doing stratified sampling, etc. It's I'm reasonably comfortable that you guys could probably do it in your sleep. The customer, that's actually a challenging problem for them to deal with because it's not what they do. So therefore we had to communicate. And so for us, it was very much around saying, well, how accurate do we need to be? And they go, well, what does accuracy mean? Well, if you want to be really accurate, then it's got a very small margin of error. Oh, what does that mean? And I'm sure everybody, all the lecturers in the truth have obviously used a dartboard. game as part of the maths going to feature in first year stats? Well, we actually did that. And people got it. And then what we wanted to talk about was actually what sort of error could we accept. And then we got an idea. I'll talk about that a bit later on. But what we also realised was if we could actually get a small enough sample that was so statistically relevant, we could actually put meters on every single house. So that's exactly what we did. And that's the meters that we put out there. So right now, there is a number of houses distributed across the entire Perth area that we're actually pulling live telemetry from. We're analysing that data continuously in real time. So it's effectively a fantastic example of IoT devices, mixed data, big data, data science, and then some stats on top of it. So we're actually really, really excited about it. What's fascinating was when we did our literature reviews for it, we actually found out that what we were talking about doing had never been done before at this scale that we were aware of. Even in California, which is probably one of the leading areas for water research, I thought it was pretty out there. Now, so for us, suddenly we're now at the absolute cutting edge of research. So now it becomes an applied research problem. How are we going to make all of this stuff work together? Now, we were talking about area before. I went down the path of, cool, stratified sampling, it's going to be very basic. Age, gender, socioeconomics, ABS data, we're good to go. So I've got my instrumentation in the field, I've got my big data, I've got some stats, I know what people are doing, we'll make it all put it all together and ensure we work. But, as we've said before, we have to look at regions and household land sizes. And apartments, quite frankly, suck because they're really badly instrumented. So what we're now finding is there are gaps in our data as well. How do you accommodate that? Can you use inferencing? Can we create synthetic data? Can we just actually do resampling in that particular area? So suddenly we ended up in a situation where we had to start playing around with a whole pile of sampling problems. But, comes back to a key question, how accurate do you want it to be? The more accurate you want it, obviously the more money you need to spend, and actually the more precise you have to be in your sampling methods and what you're going to do. So, for us, what we decided was once we went down the path of choosing the groups, choosing land sizes, we started then playing around with how do we actually go, what's the smallest statistically relevant size that we can get away with? For us, and to give you context, for every house that we had to go and put in a meter on, it cost about $1,000, and it would take somebody 4 hours to wire them on. So how do we make sure we have enough coverage based upon the urban form of Perth? How do we accommodate both old buildings and new buildings, infilling, etc.? So suddenly what we're finding is that we have to be very careful in how we create our subgroups. And then ultimately, we have to keep it simple enough that the customer understood it. Because they need to be able to explain it to the executives, we have to be able to explain it to the minister, so that everybody understood what was going on. That for us was a real challenge, because what we realised is the more technically complex we became, the harder it was to explain it. The less they understood, the more frustrated the customer was, and we had to play that problem. To give you an idea, I gave a talk, and people struggle with the concept of a mean and a mode. So that's literally the level that we're playing at. So you can imagine how complex it gets if you start really going for resampling populations and all that sort of stuff. Now, unfortunately, they said, oh no, you need to be really accurate. So are you getting a theme about really accurate, not really understanding what we're dealing with, mixed data problems, and then trying to tie it all together? So what we tried to do was actually piece as much data as we possibly put together and then started looking at different sampling techniques. As part of the sampling techniques, we were focused around land form, land use, and then from that, mapping it out and then trying to figure out what would be a representative sample. And it ended up being 2,000 surveys, 1,500 metres, and 400 audits. When we first put these numbers up, to put in context, that's $3 million worth of work. So it's not a cheap exercise at all. So, internally with the Water Corp, they went, wow, that's really expensive, we want less. So we go, that's great, and then your margin of error will increase. And then they go back to the same question, what's margin of error? Well, deep breath, let's explain it again. And then what we actually realised was we needed to actually fix something. It didn't matter what we fixed, but we needed to actually lock it down. And so what we decided was that a margin of error of 5% was actually acceptable. Now, there's lots of techniques which we've used to come up with 5%. It was really easy. That was actually the error that they had in the budgets. And that's how it was done. Alright, really complicated stuff. But you can start seeing what's fascinating is for long as the total margin of error was less than 5, it was good. Now, what's interesting is this was what we thought would be the best approach. And we thought that they'd give us the best coverage and it would be quite a good technique to fit together quite nicely into the style set. What we then discovered was actually it's really hard to actually get that number, some of those buildings of that scale and size in Perth. So we came up with what we thought we would need, but then when we actually looked at the physical world, it was different. So that was a bit of a challenge. But it's okay, because I had Corey, an inherent team sort of that, so it's great. I just pay for the coffees. And then what we tried to do was move it more into setting quotas. And the reason why we've done this part was based upon physical limitations, what we're dealing with. And so, for long as we met our 5% error, it was an acceptable approach. Now, what's really interesting is you get some really cool, so northeast corridor, number of houses, 4. So even somebody with stats about as mine, now that's not a really big number, right? But overall, it will work. And it comes down to purpose. This piece of work is a directional piece of work. It's about understanding how households use water across the entire metropolitan area in order to set directional outcomes. In that context, it fits together quite nicely. Now, what's fascinating was once people realised what we were doing, people wanted to come along and put all sorts of weighting conditions in the data, and scaling data, and what else did they try to improve? Pretty crazy. So, for us, it was an interesting experience. So, overall, some of the stuff that we were interested in doing was actually setting up sampling periods, behavioural studies, The reason why we chose 4 behavioural studies was seasonality. So as we were going through, we're starting to work out what are the drivers of water use. Obviously behaviour. So we'll do the surveys over, 4 surveys over the course of a year. We managed to get 1,942 digital devices out there, which is pretty neat considering our target is 2,000. And surprisingly, it actually worked, which was even, well, most of them are working. We did have a few problems. And then what we were also able to do is actually look at creating a subset. So we're able to now look at houses where we only did audits, don't do audits. We're able to keep water use diaries. And then we can also use new product testing. So we actually moved a sample space across, because what we found was the marketing team really wanted a group that they could actually play with. So the idea is they'd send these guys specific brochures to see what their behaviour was. So we now start looking at behavioural response. So if you imagine, we're now looking at behavioural response based upon types of households, based on landforms. So you can start seeing how it's all being packaged together. And that gives us a really great story and gives fantastic insight into what Water Corp's doing as part of the long-term strategic planning. So we're quite proud of the piece of work, and we're very fortunate to actually win the overall national award for data insights for this with Water Corp, which is quite cool. And so we get to go up to, I think, the Worlds in Vietnam, where it might be. What was interesting was when we presented to the judges, and I wasn't part of the team presenting, the judges said it was a really innovative approach for applied stats for a mixed data set in an urban form. So that was actually what they said was really cool. So there you go.